Now we're going to do two problems where we use the linearization. So remember, we saw in the last video that L of x is equal to f prime of a times x minus a plus f of a. Okay, so this says, the first part says, find the linearization of f of x equals the square root of 2 plus x at x equals 2. So that's actually our a value. So a equals 2, so that means we need f prime of 2 and we need f of 2, which f of 2 would be the square root of 2 plus 2, which would be the square root of 4, which is 2. Now, to find our derivative, so this is 2 plus x to the 1/2, so our derivative is 1/2 2 plus x to the minus 1/2. We'd multiply by the derivative of the inside here, which is 1. So this would be 1 over 2 square root of 2 plus x. So if we plug in 2, 1 over 2 times the square root of 4. So we'd get 1 times 2 times 1 over 2 times 2, which is 4. So 1/4. So our linearization, plugging all these pieces in, f prime of a was 1/4. Then we're just going to have x minus 2 plus our f of 2 was 2. So that's our linearization. Now this says use this to approximate the square root of 5. Now we need to look in here, what x value would make this the square root of 5? Well, that would be 3, right? Because then we'd have the square root of 2 plus 3. So we're actually looking, square root of 5 here will be approximately L of 3. So we'd have 1/4 times 3 minus 1 plus 2, or sorry, 3 minus 2 plus 2. So we get 1/4 times 1 plus 2, right? So this would be 9/4, right? Which 9/4 is 2.25. And if you put the square root of 5 in your calculator, you get 2.236, right? So pretty close. And at least something that you could do, you know, you'd be able to do all of this without using your calculator at all. And what we're saying is, if you were stranded on a deserted island and needed to have an approximation for the square root of 5, this would have been a way to do it. Okay, so this says use the linearization of f of x equals the cube root of x to approximate the cube root of 8.5. So what we need to do is pick an a value, since it doesn't give us one, close to 8.5, where the cube root of a, oops, I just gave that away accidentally, a is easy to determine. Right, so we need something that the cube root is easy to take and it's close to 8.5. Well, a being equal to 8 would be a good choice because the cube root of 8 is just 2. So we're going to let a be equal to 8. So remember that our linearization is f prime of a times x minus a plus f of a. So our a is 8. So f of a, the cube root of 8, is just going to be 2. Now to find, so if our function f of x is the cube root of x, that's the same as x to the 1/3. So our derivative is 1/3 x to the negative 2/3, and that would be the same as 1 over 3 the cube root of x squared. So if we put in 8, we'd have 1 over 3 the cube root of 64. And the cube root of 64 is 4. So we'd have 1 over 3 times 4, which would be 1/12. So here we know our L of x is equal to 1/12 x minus 8 plus our f of 8 was 2. Okay, so now, so that's the first part. And now we want to approximate the cube root of 8.5. So since our function was just the cube root of x, we're going to plug in, we want L of 8.5. And we'll use that to approximate the cube root of 8.5. So L of 8.5 is equal to 1/12. 8.5 minus 8 plus 2. So that's 1/12 times 0.5, which is the same as 1/2, plus 2. This is 1/24. Now 2 would be 48/24. So we can see that this would be 49/24. So that would be our approximation of the cube root of 8.5. Which 49/24 is, so this is about 2.041 and then 6 repeating. And if you do the cube root of 8.5 on your calculator, cube root of 8.5 is 2.0408. So you see, at least up to 2 decimal places, we get the same thing here using this approximation method.